All right, so welcome back to a quick introduction to part two, everybody. We just got done going over our notes for a square, the area and perimeter, and we're about to fill out the same notes that you see on the screen for rectangles. So let's go ahead and take a look here, everybody. We have our formulas just like we did in yesterday's class. So if you're here, take a moment to write this down if you haven't had a chance to already. I wholeheartedly recommend going over yesterday's basics class before you come into part two. But if you're here and you're confident, let's go ahead and get into it. So let's go ahead and go over some conceptual things, some things that we want to understand. If we're dealing with, let's say, this rectangle on screen, let's go ahead and say we're discussing the perimeter. If we're discussing the perimeter, everybody, of a rectangle, and let's say the units for each of the sides are going to be measured in, let's say, centimeters. So blank centimeters, my party people, if we're calculating the perimeter, what are the units going to be? Is it going to be centimeters, centimeters squared, or something else? Now, it looks like the majority of us are lining up to say centimeters flat out, and that is correct. Now, I want to remind everybody, remember, perimeter is just a distance, the distance around the shape. So nonetheless, again, distance units, they're singular, centimeters, feet, miles, not centimeter squared, miles squared, or anything like that. That represents space, how much space you're covering. A singular unit is from A to B. So with that said, let's go ahead and discuss area, just like I gave that hint. Everybody, when we're discussing area, is that going to be centimeters or square centimeters? Which one is it going to be? Correct, it is going to be square centimeters because, again, just as a reminder, area is two-dimensional. We multiply the length and the width together to create a two-dimensional unit. So with that, everybody, that is it. We are ready to dive straight into the practice problems today. So the way that we're going to handle this is we're going to begin with a timer. If you're watching this as a recording, feel free. Get that timer ready. Time yourself for 2 minutes for these first couple of questions, or you can go all the way up to 3 minutes to see how well you do, or take as much time as you need. But with that said, everybody, let's go ahead and get ready for problem number one. All right, so let's move forward here with our first question of the day. We always want to begin, per usual, with the question sentence. So we see here that it says, what is the area of the pool? And just like in the previous class or the previous times that we've talked about this, the moment that you see one of those hyper-specific geometry words, like area in this case, we always want to ask ourselves, well, what shape? Because remember, depending on the shape, the formula for the area might be different. So with that said, everybody, in the chat box, what is the shape that we're dealing with? We know that we're dealing with, yep, right there, a rectangle. So we know that we're dealing with the area of a rectangle. So before I even continue, I'm just going to remind myself that I want area, and I know that the area of a rectangle is going to be length times width. And I'll just have that written down because guess what? If I want the area of this rectangle, it really looks like all I need is the length and the width. If that's given to me, great. If not, I'll have to figure out what to do. So it says that the swimming pool is 20 meters long, 8 meters wide. So with that said, nice and easy, the length is going to be 20 and the width is going to be 8. So we have that together. So the area is going to be 20 multiplied by 8. 20 times 8 is going to land on 160, but that's not what I care about. Let's go ahead and remind ourselves what the units are going to be for this solution. What are the units going to be? Yeah, they're going to be meters squared. So you can say m squared or meters squared. Either way, it means square meters, so you're good. But there we are. There we go. And we are all set. The correct answer for the first question is B, 160. So feels like a pretty straightforward question, but let's go ahead and turn our attention over to trying another one out. So here we go, my party people. Let's keep it going. All right, on to the next one. In this question and every question, remember that our first task is going to be, well, what's the goal? What's the goal? Why are we looking at this? Why do we care? So it says over here, what is the width of the garden? All right, sounds good. So given that I see a somewhat geometric term here, again, width, It doesn't mean that we're dealing with, solid shapes like squares, rectangles, triangles, things like that. But we want to see if there is a shape being mentioned because it might be important later. So we want to know the width. Let me just go ahead and write that down. I just want to know the width. But when I start scanning around and reading my information, I want to take note of any shapes. And I see that right here. Consider a rectangular garden with a length of 12 feet and an unknown width. That unknown width is right there. We don't know it. Okay, sounds good. So I know what the length is. Let me highlight that here in blue. The length right here, 12 feet. And then we continue reading. Again, just take your information in, imagine what you can, visualize what you can, and keep it moving. A gardener walks completely around the garden, covering a total distance of 34 feet. So if I were to say that this 34 feet, this measurement given to us here, if I were to say that this was the perimeter given to us, who here can tell me for what reason? What words could I highlight or circle or underline to really prove that, this is a perimeter and not an area given? Okay, cool. So I see a ton of answers here in the chat box. My favorite answer is from Betty saying around it. Yeah, right here. Again, a gardener walks completely around the garden. That's going to be massive hint number one. Walks completely around the garden. And then you see that it says distance, and you see that your distance is measured in feet. So when you think about that, my party people, that's what this is about. Being able to prove that you know what the number means. It's not just about, hey, this is what it is, but you want to know why it is what it is, how it's going to help you get to what you want. So with that said, we have our perimeter. We'll write it down right there. And now the only question we want to ask ourselves is there a connection between the width, the length, and the perimeter? Can I somehow use the length and perimeter of a rectangle to get the width? And the answer is going to be yes. Absolutely. There's always going to be a way. And this is where we have to remind ourselves of that formula. The formula for the perimeter of a rectangle specifically is going to be double the length plus double the width. And so with that, sounds good. Let's go ahead and plug everything in, and then we'll solve. The perimeter right here, we're going to replace that with 34. That is the perimeter given to us. Then the length that we're given is 12, so I'll do 2 times 12. And then we'll write everything else in place. Now remember, we're trying to get that W by itself. We're trying to get this width all by itself. So we're going to clean this up, the 2 times 12, then move it over to the left side if we can, then get rid of that 2 if we can. Let's take it one step at a time. 2 multiplied by 12, that's going to be 24. So we write that 24 right there, and we'll go ahead and add the 2W at the end. Next, we got to get rid of that 24. We can get rid of it by subtracting 24 on both sides. Remember, a 24 that's just sitting there, we can really consider that adding a 24, plus 24. So to get rid of a plus 24 that's just sitting there, we'll go ahead and subtract it. And again, on both sides. So once we do that, booyah, one step closer to victory. So 34 minus 24 gives us 10. 10 equals 2W. Again, that's what's left right over here. We'll divide both sides by 2, and that's it. We're done. We just have to make sure we know how to plug the right things into the right places, and then solve the equation from there. So the missing width is going to be 5 feet. Answer choice B is correct. And there we are. All right, let's take a look at our next one here. The first thing that we look at, as always, is the question sentence. So here we're asking, what is the area of the resulting figure? Okay, that's a little weird, a little ominous, a little different. My party people so far, can you tell me, does this specify exactly what shape we're dealing with? Because I see the word area, but does this explicitly say what shape we're looking at as the result? Like what the resulting figure is? I know I see square right here, but we got to be very careful because they're not talking about the existing figures. They're talking about a resulting figure. So first things first, let's play it safe. Let's get those keywords out. It says, what is the area? So that's all I'm going to write down at first. I want the area of this new figure. Okay, sounds good. Now, let me really contextualize this. Let me understand what the heck this prompt is saying. So, two congruent squares with sides of 5 centimeters are joined edge to edge. Okay, let's go ahead and imagine that. When in doubt, let's draw it out. So here we go. I'm going to draw a little square over here. Perfect. And it says that it has side lengths of 5 centimeters. So we'll do that there, and we'll do 5 centimeters over here. Nice and easy. Now, quick question, everybody. What does congruent mean? Because it says we have two squares, and it says that these squares are congruent. What does congruent mean again? Yeah, it means that they're the same. So we have two squares, not just one. We have two squares that are 5 centimeters apiece. Let me connect them right there. So 5 centimeters still at the bottom, 5 centimeters right there. My party people, quick question. If we think about this, these two squares joined edge to edge, because again, this is an edge, they're joined edge to edge. What shape are we dealing with? Yeah, we're dealing with a rectangle now. So everybody, when we think of the area of this new figure, what shape are we going to use the area formula for? Yeah, it's just the area of a rectangle. So when we think about, again, when we draw out, when we visualize what the story is saying, before we get hung up on the numbers, we get to really see the bigger picture. So all they're really saying is find the area of this resulting rectangle when we put these two squares together. And the formula for the area of a rectangle is just going to be the length multiplied by the width. And so the width right over here, I can say it's 5 centimeters. But when it comes to the length, I see that that's going to be 5 centimeters and 5 centimeters together. Right there. Everybody, can we see that this rectangle here, the area of this rectangle is the length times the width? And we notice that we have the length being both of these 5s together, and the width is just the 5 right there. But the bottom is what we really have to pay attention to, right? We see that the length is different. We see that it's 5 plus 5, and I'm not going to patronize anybody, but what is 5 plus 5? Yeah, that's going to be 10. So I'm going to grab that. Bam. This is going to be 10 multiplied by 5. Everybody, 10 multiplied by 5 is going to be what? Yeah, that's going to be 50. Right on. Area equals 50 square centimeters. And we're good. But I want to make sure I convince everybody here. I don't want to put you in a position to think of this as, oh man, so I had to realize that this was a rectangle for me to get this right. Well, not really. Everybody, one more time, help me out. The word congruent means what again? The word congruent means the same. Exactly. So if they're both the same, let's just zoom in over here and really think about this rationally. Let me grab my eraser and get rid of that highlight, and then just separate these two squares. Just like that, nice and easy. So I'm going to change the color over here. Let's change the color to some orange. I think that'll work. Yeah, that works just fine. Everybody, what's the area of a square going to be? The area of a square is just going to be side times side, right? Side squared, as some of us might say. So help me out. What's the area of one of these squares? That's going to be 5 squared. Everybody, what's 5 squared going to be? Yeah, that's 25. So we have 25 square centimeters for just one of these squares. How am I supposed to get the area of 2 of the same squares? What do I do to the 25? Right, you just add it together. That means that this is 25 square centimeters as well. If you add those together, 25 plus 25, which is the same thing as saying 25 times 2, we end up getting 50 square centimeters. So there are 2 ways to get this problem right. But essentially what you're doing is just, hey, we are bringing these 2 squares together, and so we are getting the total area, add the areas together. My party people, does that make general sense to you, yes or no, before we continue? All right, sounds good. So let's go ahead and move it forward. Let's try another one out. All right, so looking at this next one here, we're going to assume always, no matter what, that we're doing a brand new question because we don't want to risk getting confused or getting tricked by some of these benign looking questions. So as always, first things first, what is the area of the resulting figure? So again, it looks like we put something together, it looks like a shape, and we want to know the area of that shape. Okay, sounds good. So the area of the shape, well, I got to know what shape it is to know what formula, or to have an idea of what formulas to use. But just like the previous question, it says two congruent squares. So congruent meaning the same. So two squares that are the same with a side of 7 meters are joined edge to edge. So when we think about that again, just like we did in the previous one, 7 meters for each side. And again, we have a duplicate of it right over here. And this one again is 7 meters by 7 meters. Now, when we join them together, boom, you can consider that a rectangle. Or since because it's just the sum of the areas, we can think about it as two separate squares. Either way works just fine. So if you think about it like that, like the area of square 1 plus the area of square 2, well, we can say that the area of the first one is a square, so it's 7 times 7. And the area of the second one is just 7 times 7. We can think about it just like that. And so if we bring this down a notch, let's go ahead and write this out. 7 times 7, everybody, is going to give us, that's going to be 49. Nice and easy. And if we add that with what we know the other area is going to be, 49, add both of these together and we will get 98 square meters. Because the first one is 49 square meters, the second one is 49 square meters. Add them together and we get 98 square meters. If we were to add both of these together in terms of the shapes first, we can absolutely do that. I can take duplicates of each of these, put them together, and what we would have is 7s on the side over here. This over here would be 7 plus 7 because we have, again, both sides. 7 plus 7 being 14. So if we wanted to find the area that way, we could absolutely go with 14 times 7, and that's still going to give us 98 square meters. And there we go. Again, two different ways to do the same exact problem, because in this question, hear me out, in this question, because we're looking for the combined area, we know that area is the space that we cover. So with that said, hey, the space that we cover can be the sum, the addition of these spaces individual. So with that said, let's go ahead and take a peek at the next one, give it our best try, and as always, learn from any mistakes that we might make. We got this. All right, looking at this next question, no matter what the question is, we're always going to read the question first. So the question sentence that is. So it says, what is the perimeter of the resulting figure? So already, if we've been watching this as a series, we may have noticed that the previous question asked us for the area of these combined shapes. But here we're talking about finding the perimeter. Very different. Very different. Everybody, as a reminder, can you help me out? When we're talking about calculating the perimeter, we are strictly adding the distance up on the what part of the shape? We are strictly adding the distance along the blank part of the shape. Starts with an O. OU. We're talking about the outside of a shape. That is correct. So keep that in mind. You know, we have this hyper-specific geometry word, perimeter. We all know that that means that we are adding up the distance on the outside of the shape. So with that said, let's take this into account. We have the same premise, the same story, the same situation. Two congruent squares with side lengths of 4 inches are joined edge to edge. So let's imagine that. We have right over here 4 inches by 4 inches, and we are connecting this with a duplicate. Again, a congruent square, and we're going to connect it right there. So we have 4 inches there and 4 inches here. Now, my party people, let me ask you this very honest question. Who here went ahead and said, well, look, the perimeter of a square is going to be 4 times the side. And so the perimeter of one of the squares is 4 times 4, which is going to be 16. And when you saw that you had the perimeter of one of the squares, you said, hey, I'm going to multiply it by 2 since it's 2 squares. And when I do that, 16 multiplied by 2, you ended up getting 32. Who here felt like, hey, I did that, I got 32, and I selected D for that reason? Okay, again, thanks for being honest. Thanks for being honest. This is where I'm going to reveal that, yeah, that's going to be incorrect. That is the incorrect answer because this is not the same exact problem as the previous question. It's not. Let me go ahead and just entertain this for a second. Everybody, when we think about perimeter, we think about the outside of a shape. So everybody, when we look at this, follow along with me. We would take the perimeter here. We would go here, the right side, the top side, and the left side. We would add all of these together. And then we would add all of these together to find the individual perimeters. However, look at what's going to happen, everybody. Look at what's going to happen. Pay attention specifically to this side over here and specifically to this side over here. Watch what's about to happen. When we bring these shapes together, are we counting this anymore when it comes to the outside of the rectangle? Are we counting this anymore? No, we are not. We are no longer counting this. We only care about this side, that side, that side, that side, that side, and this side. We do not care about that. So because of that, everybody, we need to think about this new shape strictly as a rectangle. We are going to ignore where they join together because that's not perimeter anymore. This on the outside is perimeter. So we can do it a couple of different ways. When we take a look at this, we can wholeheartedly say that, hey, look, we just have 4 inches here, 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 and here. We add all of that up, and that's 6 of them. 1, 2, 3, 4, 5, and 6. So if we wanted to think about it like that, we could do 4 times 6, and that would give us 24. We could also treat this like a rectangle. Everybody, quick question. 4 inches plus 4 inches is going to give me what? Yeah, that's going to give me 8 inches. So if I count that right there on the bottom, that's 8 inches for the length, 4 inches for the width. And if you really want to feel safe and secure here, for sure, you can go ahead and use the perimeter of a rectangle formula. Double the length plus double the width. We know that the length is 8, so 2 times 8. We know that the width is 4, so 2 times 4. Perform those products, the multiplications. So 2 times 8, that's going to be 16. 2 times 4, that's going to be 8. 16 plus 8, and that's going to give us 24 total inches. Again, we do not count those sides that ended up joining together because that is no longer part of the outside of this shape. And there you go. Again, having that understanding of what the story is leading you to and not just reacting to every number that you see is going to help us understand that D is not the answer, but instead it is C. Everybody, are we feeling slightly better about this explanation, especially if we were on the side that picked D? And there we go. And yeah, if you were part of the crew that got C at first, again, as long as you were able to explain your rationale, if you were able to convince yourself that, yeah, I know I'm right because of X, Y, and Z, because of this and this and this, then you're doing a great job. All right, next one up, everybody. So as always, read that question sentence. We have the grace here of looking at just one sentence as the entire question or the entire problem, so no worries. But here's what we're doing. We see that we're given a square, we have its side length, and we want to know its area. So with that said, the only thing that's really going to be intimidating about this question is probably going to be the decimal. But don't let that distract you from the fact that we are calculating again the area of a square. So the first thing that you should be ready to, really spit out is the formula for the area of a square. And that's going to be area equals the side length times the side length. So side times side or side squared. They're both the same exact thing. But when you take a look at this, you are pretty safe in knowing that all you need to do is plug in the side, which is already given to you right here. So I know it's already given to me. So let's plug it in and let's solve. 9.5 multiplied by 9.5. So with that, I'm going to zoom in over here on the side, and we're going to calculate this. But I'm going to remind you that there are rules to multiplying with decimals. So let's write this out over here. 9.5 multiplied by 9.5. So here are the rules for multiplying by decimals. Step 1, we're going to ignore the decimals. Ignore the decimals, and we're going to bring the decimals back at the end. So bring them back at the end. At the end. So that's it. So with that, yes, that's right, Giovanni. That's part of the math basics. Math 101 there. And that I'm talking about the course, not, metaphorically. So with that, here we go. 5 multiplied by 5. That's going to be 25, and we will carry the 2. From there, we have 9 multiplied by 5, and that'll be 45, and we'll carry the 2 to get 47. Sweet. There we go. We have just finished taking care of this 5 right here. Now we'll move forward to taking care of the 9 over here, which means that we have to start that 9 on the second place value. I'll make this a little more clear, so I can just go ahead and do that. You see the space, the places that we're working on. So because of that, we'll go ahead and put a 0 here so we can start in the right place. Let's get to it. And let's draw this little line. So here we go. 5 multiplied by 9. That's going to be 45. Carry the 4. Then we have 9 times 9, which is 81. Carry the 4 is going to be 85. And so from here, my party people, we're just going to add like normal, like we've just multiplied like normal. 5 plus 0, 7 plus 5, that's going to be 12. 4 plus 5 is 9. Carry the 1 is 10. So we'll carry that other 1. And then we have 1 plus 8, which is 9. So we've done step 1 completely. We've ignored the decimals. Now we have to bring the decimals back. So what do I notice? I notice that we have 1 decimal place here and another one over here. So 1 decimal place there and the other one there makes 2 total decimal places. So we'll go 1 and 2. And so the final answer is going to be 90.25. That is our final answer. And given that we were looking at units, it is 90.25 square units. And there we are, my party people. The answer choice here is going to be choice A. This was just a brief reminder to make sure you know how to deal with decimals, because some of the questions can be this straightforward. They can be this easy, but if we are not set in our foundations, then an easy question can slip away. Let me know if that makes sense, my party people. Let's go ahead and get ready for the next one, per usual. All right, let's take a look at this unique looking question. And as always, I sound like a broken record, but we are going to begin with the question sentence. So the question sentence, even though this is a short one, it starts right here. How many steps are needed to circle the rectangular field that measures 120 meters by 80 meters once? So hear me out. Let's break this down. Right here, I'm going to highlight in red how many steps. Okay, so that's what I want to know. Let me define the context of that in a second, but I need to know the number of steps. That's all I know so far. Now it's saying that we're trying to figure out the number of steps that we need to circle a field, to circle a rectangular field. Everybody, can you help me out really quick? Because I saw 2 shapes here, but can you confirm, does the word circle here, is that talking about a physical shape of a circle, or is that an action? Yeah, that's an action. That is an action. So remember, everybody, circling the field means, hey, you're going around the field. So if this is a rectangular field, I'll go ahead and draw this out right over there. So if this is our rectangular field, if we're circling the field, that means that we're going around the field. So before I continue, does that make a little more sense? Again, the word circle just means going around this rectangular field that we have. Perfect. Now, I know some of us might look at that X right there and think that that's multiplication, but again, that is not multiplication. They are simply giving us the dimensions of 120 by 80 meters. So that's what we have right over here, 120 meters by 80 meters. And we want to know how many steps it'll take to go all the way around this field. That's what we want to know. So be very careful here because you might think of this as, hey, going around the field. I heard you, coach. That means perimeter all day. You're absolutely right with that first thought. But there's a little more thinking that we're going to need to do. So hear me out. We have perimeter, and for a rectangle like we see over here, the formula is double the length plus double the width. But the thing is, everybody, what are we trying to find? Are we trying to find the perimeter? Like, is that what we need to finish the problem? Correct. It's not the perimeter. It's the number of steps that we would take. So I'm going to show you how this is going to go. Nice and easy. Here we go. So we have perimeter equal 2 times the length, which is 120, and then plus 2 times the width, which is going to be 80. We find that perimeter, and that's going to be 240 plus 160. Everybody, 240 plus 160 gives us what? Correct. That's 400 meters. Excellent. All good right there. Now, really quick though, what do we do with this 400? I see a lot of us in the chat box saying we're supposed to divide. And that is correct. That is absolutely correct. But before I show you why we need to divide, or why, before I show you the actual division, let me show you why we need to divide. Everybody, what is the distance that this walker covers every stride, every step? What is that distance that they cover? Yeah, 5 meters. The walker's stride is 5 meters. Excellent. So let me show you how that's going to look. Let me go ahead and show you this. Let's say we're looking from point A to point B. Let's suppose that this is 15 meters. Let's just make it a lot shorter, right? Everybody, if our stride is 5 meters at a time, how many strides are we going to need to cover 15 meters? You tell me. To cover 15 meters, if I go ahead and divide that by 5, that's going to be 3 steps. 5 meters in the first step, 5 meters in the second, 5 meters in the third, and that makes the 15 meters. So when you think about it like this. If every step is 5 meters, which is wild, that's a pretty long distance, but if every pace is 5 meters, you divide the total distance by each step, and you'll get the number of steps. So 15 divided by 5 meters, that is 3 paces or 3 steps. Does that make a little more sense in terms of why we are dividing, my friends? Perfect. So again, the reason why we are dividing is because you have the total distance, and if you have the distance for each pace or each step, if we divide by that pace, so the distance of each step, we get the number of steps that it'll take. So if we just do that over here with 400 meters divided by 5 meters per step, that's going to be 80 steps. Again, we're not looking for a distance, we're looking for the number of steps. And that's why at the end, the correct answer here will be C, 80 steps. Oh yeah, my party people. So we're going to continue getting more and more questions in, but remember, your ability to pass this test is really going to rest on your ability to take a look at new situations and know how to apply the formulas that you have. So everybody, is it true so far for you personally that you can memorize the formula all you want, but it's not going to save you when it comes to problems like this? Cool. Sounds good. I just want you to understand, fully, all the way in your head, that even if you didn't get this question correct, you see that there are new situations, new ideas that we want to prepare ourselves to tackle. So with that, let's go ahead and keep it moving forward. Step by step, we'll get better. All right, next question coming right along here, my party people. So we're checking this out, and as always, read that question first. So understand the goal. So what is the perimeter of the resulting figure? So what is the perimeter of the resulting figure? So the key word here, everybody, again, the main thing, we always want to fixate on things that we can recognize, that we can translate. And we see that it says, again, what is the perimeter of the resulting figure? So just like we've seen before so far in this kind of class, we've noticed that, figure could be a square, could be a rectangle. We don't know what that is. Let's confirm that we know what that is before we get into it. So with that, here we go. Let's go ahead and just write down that we're looking for perimeter. And let's see what shape this is. So similar premise. It says that two congruent, so two squares that are the same, two congruent squares with a side length of 9 meters are joined edge to edge. So we can kind of draw this out like we did before, where if we had, hey, this square over here that's 9 meters on each side, if we connect that with another square of the same exact size, we see that we're going to have 9 meters there and 9 meters there. But everybody, instead of writing 9 meters and 9 meters for each of these, let's just combine them because now those are one side. So 9 meters plus 9 meters, what's that going to be? Yeah, that's going to be 18 meters, nice and easy. So we'll go ahead and erase that and bring in 18 right there. Because everybody, we're looking for the perimeter of this resulting figure. And just like before, we have to recognize that this combination, so this connection right there, that doesn't count towards the perimeter. The only thing that counts towards the perimeter is the outside of the shape. That's it. So with that, since we're looking now at a rectangle where we have a length here and a width there, again, we can clearly see that this is no longer a square. This is now a rectangle. All we have to do is use the formula for the perimeter of a rectangle, and we are good. So with that said, we have 2 multiplied by the length, so that'll be 2 times 18. Then we have 2 times the width, which is 2 times 9. So with that said, we're going to go ahead and do 2 times 18, which is 36. 2 times 9, which is 18. And now we'll add both of these together, and we are good. 36 plus 18, 6 plus 8, that's 14, carry the 1. 3 plus 1 is 5. So we see that the distance around this rectangle is 54 meters, and we are good. The correct answer here is A. Again, this was not a question where we would just double the perimeter. Since we have 2 circles, we have to take into account that they are joined right over here in blue, or in green, in green, that the 2 squares are joined edge to edge, which is right there. They are joined right there. And so we don't count the middle part, and we just take into account the outside. So again, these are good questions, right? Because even if I showed them to you, back to back, and you were like, oh yeah, I know what I did in the previous one, so I'll do that same exact thing. But notice how we have 2 different questions that we could ask for the same premise. One where we ask for the combined area, one that we would ask for the combined perimeter. And we don't just blindly multiply by 2. We have to consider the circumstance. We got to consider what's actually going on. So far, I really hope you're enjoying these problems. Even if you haven't gotten every single one correct, I really do hope that you're enjoying what's going on so far. So let's turn our attention over to the next one. Keep kicking butt. Keep having fun. All right, here's another one. Let's keep it going. What's the question? So the question reads, how many boxes can fit? Okay, so how many boxes can we fit? That's what we're trying to figure out here. So with that, let's take a look at the information that's given. Again, let's just move forward here. Let's see what we want. Because when we see the phrase or question, how many boxes can we fit? That may not explicitly state that we're dealing with geometry. So again, just take it one step at a time. So let's figure out how many boxes can fit by first understanding that we're dealing with a rectangular garden, and it measures 15 meters by 10 meters. So we have a rectangular garden, and it's 15 meters by 10 meters. Okay, nice and easy. And we see that each planter box needs 3 square meters of space. So if I want to go ahead and illustrate this, let me show you what this kind of looks like. First, let me grab what exists. Let's make it a little bigger. And everybody, here's what's going on. This is our garden. All of this area here is a garden. And we can say that, hey, this planter box, this takes 3 square meters of space. We got 3 square meters of space over here, 3 square meters of space over here. Everybody, what's the key word in this red highlighted text over there? What's the key word that I really want to underline to give myself an idea of what operation we need to do? Again, right here, which of these words in the red highlight specifically should I circle? Yeah, the word fit. Remember, everybody, when we're asking ourselves how many of one value can fit into another value, what operation are we thinking of? Yeah, we're thinking of division. That's right. Whenever we ask, hey, how many times can this fit into this bigger number, this bigger value? That is going to be division every single time. So what is it that we're doing here? We are going to take the area of the garden and we are going to divide it by the area of the planter box. That's what we're trying to do. Because if we are able to divide the entire area by the area of each planter box, we're going to figure out how many planter boxes we can fit in the entire garden. My party people, before I get to the actual calculation, does the premise of the problem make sense? Because we're trying to see how many of one value fits into another value. This is division. There we go, everybody. Again, one day better, one day at a time, one problem at a time. So let me go ahead and take what we have and make it just a little smaller. And let's find the area of the garden first. So area of the garden, everybody, what's that gonna be? Well, the area of a rectangle is the length times the width. So now we just have to plug in the values we have, which is 15 meters times 10 meters. And that's going to be 150 square meters. So we have the area of the garden. Perfect, right there. Now, everybody, what's the area of the planter box? What shape is the planter box? That's a little bit weird, right? They didn't give me a shape. Did they give me the area specifically? Did they give me the area specifically? That's right, Giovanni. Before anybody even said anything, yes, they did. Right here, because they gave us that the box needs 3 square meters of space. That's the big indicator. Remember, we talked about this plenty yesterday and today. Area is square units. So the planter box measurement that they gave us already, it's already in area form, square meters. So with that, we're good to go. 150 square meters divided by 3 square meters, that's going to end up being 50. 50 boxes can fit. And there we are. Snap, crackle, pop. We're good. Answer choice is D. My party people, how are we feeling? Are we feeling good about, being challenged mentally to look at these problems in all these different ways? Again, it's not just about knowing your formulas. It's about knowing how to adapt with the formulas when you're introduced to these new circumstances. All right, so with that, let's go ahead and get over to the next one as always. Another question, let's handle it with the same grace as always. So the question here reads, what is the length of one side of the park? All right, sounds good. So I instantly see that we want to know what the length of one side of the park is. So really what caught my eye is, again, the word park. What shape is this park? Because it could be a rectangle, could be a square, could be a triangle, parallelogram. I don't know. I have no clue. Let's just take it one step at a time. And if I read from the beginning, I see that it mentions it as a square park. Okay, cool. So we know that we're dealing with a square and we want to know the length of one of the sides. So when I deal with this square and kind of draw things out, I know that I'm dealing with looking for this. I am looking for the side length. So I'm going to highlight this right there. That's what I'm looking for. And when I take a look at the information that I'm given, it says, in a square park, a walking track runs along its entire edge. So here, over there, along the entire edge, and it covers a total distance of 40 feet. Can somebody tell me what that distance along the edge represents? It says 40 feet, but what does that 40 feet represent again? Thank you. That's going to be perimeter all day, every day, going around a shape. The total distance around a shape is the perimeter. So we know that the perimeter is 40 feet. We know that we're dealing with a square. The formula for the perimeter of a square is 4 times the side. And that side that's in this formula is the exact same thing as this side that we don't know. So we can use that. We can use that to get the correct answer and move right along. Because the perimeter, we already know it. It's going to be 40. And so when we fill that in and we have the rest written out, we are going to divide both sides by 4 and we're good. That's it. Boom, get the side by itself, and that's going to be 10 feet. And there we are, my party people. I know that I wrote that a little sloppy, but there we are. Nice and easy. Correct answer here is C, 10 feet. All right, here's the next problem. This one is somewhat unique. So let's go ahead and, like always, handle this like we know how. So it says here, what distance will one cover to reach the other? That seems a little weird. Seems a little weird, but that's okay. Let me go ahead and highlight that. So what distance will one cover to reach the other? So everybody, is it safe to say that because we're talking about two friends and they're standing on, certain places of a rectangle, we're basically going to say, hey, we're going to put these friends on the rectangle and we're going to figure out how long it is between one and the other. Is that somewhat in the ballpark before I actually confirm that? Okay, cool. Now, again, we haven't really confirmed that. It's kind of just what it sounds like, but let's confirm it with the information that we have. So it says that two friends stand at opposite corners of a rectangular park. So let's write that out. Let's draw that out right there. And from here, let's take away the filling. So it's just a regular rectangle. Okay, cool. So we will add friend A right over here. And it says, everybody, which corner relative to friend A is friend B at? Which corner? Yeah, it's going to be the opposite corner. It's going to be in the opposite corner. So with that, this is the opposite corner. That is the opposite corner. So let's go ahead and write friend B right there. So because of that, let's fill in the other pieces of information that we have, like the length and the width, given to us right over here. 180 meters, 120 meters over there. Now, everybody, let's understand what we're being asked to find. Let's see what we were being asked to find. It says, walking along the edge by the shorter route. That's how friend A gets to friend B. So friend A could go down and over or over and down. To be honest, it really doesn't matter because the distance is going to be the same. Because if it's 180 meters down here, it's going to be 180 up there. If it's 120 over here on the right, it's 120 there on the left. It's the same exact. And it doesn't matter if you put friend A over here and friend B over there. As long as it's opposite corners, you can't be wrong. You are fine. As long as you follow the directions, follow the setting that has been given to you, you're good. There's a million different ways to set it up. As long as you're following the rules, you are good. So with that, let's put those back where they were originally just for the sake of visuals. And again, we are not trying to go from here to here. No, we are going from here to here. Let me change the color of this highlighter. We're going from here to here and then here to here. So everybody, quick question. I know it says walking along the edge, but are we calculating the entire perimeter? Are we doing the entire perimeter? Correct. We are not. We are not doing the entire perimeter. Everybody look, friend A is here, friend B is here. After we go along this side and along this side, we're done. We're done. We've reached friend B. If we go down here and over here, same thing. We've reached friend B. What we are not doing is going all the way around back to where I started. No, we're just trying to get to this opposite corner over here. And so to get there, you can go up and around over there or up and around over here. But you do not need to go all the way around. And to understand that, what we really needed to do was interpret the story first. And so with that, it's just going to be 180 and 120 added together. It doesn't matter which way you go, because if you're going to go the opposite way, it would still be 120 and 180 added together. Either way, totally fine. It's the same exact value that you'll receive for the distance. 180 meters plus 120 meters gives us 300 meters. Making the choice that's correct here, answer choice D. And there it is. Again, another question where the end-all be-all was not the formula. The formula was part of the solution. So keep looking forward to more of that, everybody. We've got more coming up. You got this. All right, let's handle this next one. As always, everybody, first things first, we read that question. Question sentence says, how many crates fit on the shelf? Sounds good. So everybody, so we don't get burned twice in the same session. When we read that question, and we're saying, hey, how many of these things fit on this other thing? Can you tell me what operation might be lingering in your head, everybody? What might be lingering in your head when you're saying, hey, how many of these things fit onto this other thing? Again, the primary keyword here being the word fit. Yeah, that's going to be division. That's going to be division. Because remember, let's go ahead and say I have, let's say I have $20. Again, that's as high as my bank account has been all week long. And let's say we're trying to see how many times you can fit $5 into $20. That's division. 20 divided by 5 is 4. So you can fit $5 4 times into 20. Again, division. Fitting one value into another value, figuring out how many times it can fit is division. So knowing that, what are we dividing? We're going to be dividing, well, whatever value represents the area of the shelf, we're going to divide that by the area of the crate. Because if we divide the space that the shelf takes up by the space that each crate takes up, we will find out how many crates will fit onto the shelf. So we have to be consistent there, but let's go ahead and see what values we have. The shelf, what is that going to be? It's rectangular. It's a rectangular storage shelf, and its surface is 12 feet by 8 feet. So if I wanted the area of the shelf, my party people, if I wanted the area of the shelf, that's going to be 12 feet times 8 feet, because that is going to be the area of a rectangle, and that'll be 96 square feet. So we have that going on as 96 square feet. And everybody help me out. What was the area given to us for the area of each crate? Yeah, that's going to be 4 square feet. So now that we have both of these values, we can now proceed to divide, and we can have ourselves a good day. So let's do some long division. 4 dividing into 96. 4 goes into 9. That'll be twice. Subtract 8 because 2 times 4 is 8. And then from there, drop that 6. And we will divide 4 going into 16. That will be 4. So with that said, boom, there we go. We have 24 crates that can fit on this storage shelf. And the correct answer here, my party people, is answer choice B. 24, there we go. So with that said, everybody, that is going to conclude today's class. But I really want to say how proud I am of you guys of, again, being able to look at all of these different types of questions today and not relying on memorization, but instead relying on the understanding that you've built. Continue doing that as you continue practicing, whether it's with more videos, whether it's with practice that's timed or untimed, or practice tests. It doesn't matter. Remember to learn from every mistake, really talk about the reasoning, and really take that confidence to the next level every opportunity that you can. Thank you guys so much. You guys have been amazing to teach.